Welcome back to our channel, and in today's video we are going to solve a LeetCode problem called Backspace String Compare. So this problem will really test your ability with string manipulation and using stacks as well as two-pointer techniques. So this problem is will be really helpful for your interview. So let's get started. So we'll look at the problem statement first. So the problem statement says that you are given two strings s and t. You have to return true if they are equal when both are typed into empty text editor. And the catch here is that hash will represent a backspace character. Okay, so note that after backspacing an empty text, the text will continue empty. Okay, so that means here in our input, right, a b hash c. So this means that A has been typed, B has been typed, and a backspace character has been typed. So when we typed a backspace character, so B got removed, and then we typed C. That means our original string became just A and C, because B got removed after clicking the backspace character, that is hash. Right. So similarly, A, D, C here hash will be, backspace will be clicked and D got removed, right? So this is how after B got removed it became AC. Here also after D got removed it became AC. So these two strings are equal. So in our first example, if you see AB hash C will result to AC and AD hash C would result to AC. So these both are equal. Hence it will return true. In example 2, if you see, we saw that A has been typed, B has been typed, then two backspace has been typed. That means deleting two character that it has found. So first backspace will delete B, second backspace will delete A, resulting in an empty string. Okay, and here for T we can see C and then a backspace. So when we click backspace, this one character got removed, that is C got removed. And then we type D and then backspace, D also got removed. So these also will result in a empty string. So that's why both are empty string. So S and T becomes equal. So it is true. Okay. Now if you see in example 3, A backspace. So when A backspace, then A got removed and then we type C. So it is just C. S is equal to C. And T we just have B. So C and B are clearly not equal. So it will return false. So this is our overall problem statement. So let's look at the approach first. Okay. So to solve this problem, there can be multiple ways to do it, but let's look at the basic way or the first way. Okay. So our first way to solve this problem is by using a stack. So what we will do is here we have two lists, right? So first is S and it is T. So what we'll do is we'll process one string and we'll get a valid string by making use of stack. So what do I mean by valid string? A valid string would represent the actual result string after removing all the backspace and the character that got deleted because of the backspace. So here in this example, a result of this string should be A and C. So B got removed because of the backspace. So we'll make a use of stack to do this operation. So let's call this operation a build string. So what build string does is it will remove all the backspace character along with the non-backspace character that got deleted because of backspace. So for example, here it's just one backspace, so only B got deleted. But suppose instead of C, it would have been one more backspace, then both of this character would have got deleted. Okay. So how to do it? So to do that, what we will do is we'll make use of a stack. So let's first process the first element S. And what we will do is we'll iterate through each element, and we'll say that if it is not a backspace character, then we'll insert it in our stack. So in first iteration, A will get inserted here, and then in second iteration, B will get inserted here. Okay, and in third iteration, we saw that there is a backspace character, right? So whenever we encounter a backspace character, what we'll do, we'll pop out the top value from our stack. So B will get removed in that way. So B will get removed here, and now it will move forward, and it will look at the last character C, and it will push it inside the stack. So finally we have iterated through all the list. So our result string would be A and C, right? So S resulted in A and C. Okay. So similarly, what we will do is we will process it for the second string as well, that is T. So in T, if you see that first first character is A, so A will be inserted here, and then we'll see that second character is D, so D will be inserted here, right? And then we'll see that third character is backspace character. So instead of inserting this character, we will just pop out the top element. So in that way, what will happen, that D will get popped out, right? And finally, we see that our last character is C. So C will get inserted here, and hence the result string would be AC for T. And after processing these two strings, we'll just check that whether whether the process string are equal or not. We can clearly say that AC is equal to AC, right? So that's why it will return it true. So that is our core logic using stack. Okay. So let's look it into our action. So let's code this out. Okay. So here, to code this, what we will do is we need to have a build function, right? So we need to have a build string function, and what it does is it will just take a string, and it will have a stack, okay? And it will iterate throughout that string one by one, right, like this. So I will say that for each character, if that character is not a backspace character, okay, then we'll insert it inside our stack. Or we'll say that if it is a backspace character, okay, and the stack is not empty, then we'll just pop out, right? So if it's a backspace character and the stack is not empty, then we'll pop that character. So stack dot pop. Else elif is not a backspace character, then we'll insert it inside the stack. Okay, so that's our logic. So finally our stack will hold a valid string, and we'll return it in the form of string. This join the list and delete. Okay. Now in our main function, what we have to do is we'll have to call it for each string. So it is, we are calling it for the first string, and we are seeing if this is equal to the second. Self dot build. Okay, so if it is equal, it will be true, otherwise it will be false. That's what we have to return. Let's run this code. Okay, it's not build, it will be build string. Cool. Awesome. So we have successfully solved it using stack. But as you said that we'll look at other approach as well. And also if you'll see the constraint and follow up, so it is asked that can you solve it in O of n time and O of 1 space complexity, right? So here if you see that here we are using stack, right? So can we optimize this like without using an extra space? Can we do it? So let's see, let's look at the other approach. So in this approach we used stack, and this cost us with an extra space. Okay, so let's see if there is any other way. So here what we will do is we'll have a two pointers. First one pointing to the end of the first string, second one pointing to the end of the second string, and we will check that whether the, and we will process this pointer, respective pointer first in such a way which tells that whether the pointer that is pointing right now is a valid one or not, and if it is not valid, then return the next valid one. Okay, so for example, if you see here, the pointer pointed by S is C, so it's a valid one, right? So it will return this pointer and say that it is pointed to C, correct? And second time we'll do it for T, and it will also try to find what is the valid pointer. So it is pointing to C, it's a valid one. Okay. So it will also return C, and we'll check whether it is equal or not. So if it is equal, then we'll move forward. Okay, since it is equal, so we'll move forward. In the next iteration, what we will do is we'll decrement this pointer like this, and we'll decrement this pointer as well like this. So now again it will check, right? So it will say that is this a valid pointer? So we'll process this pointer. We'll say that is it a valid index or pointer? It's not, right? Because since it's a backspace character, it suggests that something has to be deleted. So we'll go ahead and delete it. It's not a valid pointer. So it says that what is our, then return the valid pointer. So it says that it has to be deleted, and so B gets deleted, and it will return this the valid one. So which will be point to A. Okay. So in this way, this will return A. Okay, and similarly for the next one, what it sees that this pointer is not a valid one because it is pointing to a backspace character. So it will decrement, and we'll see decrement and try to find the next valid one because D will be removed by backspace. So it will go and point to the A. Okay, so in this way, this will also return your A, and we'll see that both are equal, right? So again we'll move forward. So when we move forward, till now it says that till now whatever character we have checked, those have been compared to equal, right? So now when we move it, then we'll say that this pointer or index becomes less than 0, right? And this pointer also becomes less than 0. So this is the time that we know we have to come out of the loop and we are done with our computation. And this says that whatever we have checked for S and T comes out to be true. So these both are valid. So this is equal, right? So we check with C becomes C, and A became A. So and we have both have came out of the loop. So that's why it's a valid one. We will return true. But at any point of time, suppose S came out of the loop, right? S has processed all the array, but T is still have not pointed, and it is pointing to some character, right? It is not less than 0. So that means that there is no way that these two will become equal, right? Because there is still some characters to be processed by T, and S has already processed, correct? So even though till now everything has been, every character every valid character has been equal to T, but further processing would result in inequality because there are a lot of character that is not equal to T. So in that case, it will return false. So it will return true when both have come out of the loop. But if only one of them have come out of the loop, then that means in this scenario, then that means it will return false. And also one more thing, that suppose here, right, initially C was equal to C. Okay, so here instead of C, if it would have been something called L, right? So in this case, what would have happened is C would not have been equal to C, but in this case, C would have been equal to L, and which would have resulted in a false, right? So at any point of time, if we have encountered inequality, then we will return false, saying that we don't have to check further. We have already seen that a character doesn't match, so we'll return false. Okay, so this is our overall idea of solving it. Let's look at the code now. Okay, so I'll remove all this code first. We have gone through stack and we used an extra space. Now this is the two pointer technique. So since initially both pointer would be pointing to the end, right? So initially both will be pointing to the end, right? So we'll have S pointer equal to length of S minus 1, and we'll have T pointer pointing to last index of T. Now we'll run the loop until one of them becomes less than 0, while SP is greater than or equal to 0. We'll run it, or any one of them, or TP 0. Or let's just say that we'll run it until both are, both are less than, both comes out of the loop. We'll run till that point of time, and we know that after it came out of the loop, that means all the string has been processed correctly, so we can return true at the end, saying that both the string has been processed correctly. That's why both of them came out of the loop. So we can say that we can both are equal, and we can return true. So inside this loop, what we will do is for each iteration we'll subtract 1, and we'll process this string. We'll process it in such a way that first string, right? So let's denote it first index, or first pointer, yeah. So first pointer would be get valid index. Okay. So what is the valid index? Get valid index. So here it will take s as an input, and for second tp also will say get valid index, and will take t and the index. sp was our index, and here it is tp. Okay, so get valid index, and we'll take string and the index. Okay, so this will be our function. So after you call this function, what will is whatever index it has returned, we'll just see that whether the character pointed by the respective index is equal or not. Okay. If it is equal, or rather we'll say not equal, but we'll see that if both have, after processing this, if both have come out of this bound, right, out of this array, that is if both have been reduced to we are starting from the right, if both have moved towards the left and it has reached the end of the array, right, so if both are less than 0 at the same time, then we can say that we can return true, right. And other condition is that if either one of them has returned is less than 0, or will return false, saying that if, like, if s has moved here but t has moved somewhere here, like that, that means that there's still some character that has not been processed by t, some extra character. So t's length will be more than s, and it will obviously be not equal. So this, if either one of them has moved outward, then we can clearly say that it will not be equal and it will return false. And there is one more case, that if the character pointed by the respective string is not equal, if it is not equal, then we can clearly return false. Okay, and if none of them executes, then we'll move ahead, and then that means that uh, the number, the character pointed by sp of s and tp of t is equal, and that's why we'll move towards left to check another character, next character. Okay. So let's build the logic of get valid index. So in get valid index, what we'll do is we'll have a backspace count. Okay, so suppose, like here in example 2, if you see, there are two backspace, right. So we need to so initially it will be pointing to the first uh, backspace, and we'll need to find a valid index, right. So we'll see that how many backspace are there, how many element I have to remove it to get our next valid index. So there are two, right. So after we get two, then we'll remove this two, and then we'll say that -1, right. So it will lead to the out of bound, so it will say that that is our valid next valid index. So backspace count will say, we'll hold it as 0, and then we'll run the loop. We'll run the loop till when? Till our index is greater than 0. Okay. And we'll say that if it is a, if s of index is a backspace character, right. So if it is a backspace character, then our backspace count would be increased, right? And also our backspace count will be increased, and we'll check for the next one. So that's why index minus equal to 1. Okay. Next is what we are doing is, if it is not equal to backspace, right? If it is not equal to backspace, then we'll have to check whether our if we have already encountered some backspace character or not, because in that way we have to remove those characters, right? So what I mean, I'll explain you it visually. So suppose let's take another example. So suppose for this example, here initially this pointer is pointing to backspace, right? So when it encounter backspace, then it will increment your backspace count, correct? So backspace count would be 1, right? Then it will move towards the left, and then it sees that there is one more backspace count, right? So when it is moving, that means we are decrementing our index. Okay, that's what we are doing here. And second time it found that there is one more backspace, so that's why it moved towards the left, as well as uh, it update this backspace count value to uh, 2, right? Saying that there has been 2 backspace that is encountered. Okay, so if there are any backspace character that is greater than 0, indicating that there has been 2 backspace character that is encountered, so and it is now it is pointing to a non backspace character, that means we have to remove this character, okay, until and unless this backspace becomes 0. So that's why what we will do, that if it is a non backspace character, like here it is B, right, and we have backspace count greater than 0, right, then what we have to do is we'll have to decrease our backspace count. First we'll say that we'll decrease our backspace count to 1, and also we'll update our index, saying that move forward, check for the next. Okay, so in that way this index will move towards the left. Now here it says that still we have a backspace count 1, so it will decrement again, and by decrementing it will become uh, 0 now, and this will move towards the left, so now it will point to nothing. Okay, like suppose for example there was some character here, right, like k, backspace is 0, but our pointer is pointing to this k. Okay, so in such case it will return this index. Okay, so when it found a non backspace character and our backspace is 0, that means it is a valid uh, index, right? So in such case I have to break it, so saying that else, right? So else means or L if it is simply a non backspace character, right? It is simply a non backspace character, so I have to break in such case. So break means I'll have to come out of the loop, and I'll have to return that index. Should be, I have to return that index, and here I can do this index minus, since because it is common. So at the end of the Okay, so that's our idea. So if we find a backspace character, then we'll go towards the left trying to find the next valid index. And if it is a non-backspace character, we'll see if our backspace count is more than 0 or not. If it is more than 0, that means we have to delete and move towards the left. But if it is already 0, then we'll say this is our valid index, so we'll return that. Okay, so this is the logic for the get valid index. So that's it. So this is how we get our valid index, and we'll see that the character pointed by both the string is equal or not. If it is not equal, then we'll return false. And if both have been out of the bound, like it has become -1 by decrementing this index, and both have reached the end, that means all the character have been tested out and it came out to be equal, so we are returning true. But if only one of them has been reached out of the bound, that means we can return false, because the other one is still yet to be processed. That is our logic. Here we are not using any space. Like in stack approach, we have used an extra space, but here we are not using any extra space. We are rather making use of two pointers, SP and PP. Okay. So let's run this code. Get valid index is not defined. Okay, so get valid index. Cool. Let's submit this code. It should be false because this would be removed. So what happened? Here I think we are missing out one thing, the logic of the while loop. So instead of AND, we need to have OR, because by using OR, what it means that if any of the pointer is still not out of the bound, we will keep on running it. Okay, but when you give AND, then what became is like, if one came out of the bound, then it just exited the loop and it returned true. So that's what happened here, right? So when it was AND, then here for this the next valid is B, but for this the next valid would be B, so it will reach its left bound faster and it became less than 0, and but it has not reached less than 0 yet. It would be pointing somewhere in the first index, right? So at that point of time it came out of the loop and it returns it true, so which is wrong. So instead what we have to do is we have to make it OR, so that until and unless there is some pointer, we'll keep on checking, so that finally it has come out of the boundary, but it has not yet come out of the boundary. So at that point of time this condition will run and it will return false. Cool. Awesome. So that's how we have solved this problem successfully. So we have solved the backspace string compare successfully. This will really be helpful for strengthening your string manipulation technique and playing with two pointers, right? And also usage of stacks. So it will really help you in interview where you can showcase your skills with stacks, two pointers, and if any new problem statement would be given, you would try to apply different approach, and this could be one of those. Okay. So if you found this video helpful, then please give us a thumbs up and subscribe to our channel for more coding question and interview preparation. And don't forget to hit the bell icon to get more updates with our new videos. And if you have any question, suggestion, then please put it in the comment box. I'll see you in the next video. Thank you so much.